Hello, my name is Cade Troutman, and today I'm going to be talking about one of my favorite sports, ping pong, and specifically the ping pong paddle that is used in that sport. What made me want to talk about this was because I've been playing ping pong a lot recently, and it's kind of interesting to see how different an expensive paddle is from a cheap paddle. And it made me wonder, what exactly makes an expensive paddle so much better, what materials are going into that. And yeah, just looking at it from a material science perspective has been really interesting. Paddle is basically just three major components stacked together. There's the wooden blade in the center, which gives the paddle its shape and stiffness. On each side of the blade, you have sponge layers that create cushioning. And finally, the outermost layers are the rubbers. The red rubber on one side and the black on the other. The rubber layer is the most critical part because it controls grip, spin, and speed. Small changes in rubber chemistry or thickness can completely change how the ball reacts. The design of paddles has evolved a lot. In the late 1800s, players used bare wooden paddles, so the game was really slow. In the early 1900s, rubber sheets were added, which improved grip and gave some players more control. Then in 1952, the introduction of sponge layers caused a huge shift. Suddenly, players could generate way more speed and spin, which completely changed the sport. Today, paddles use advanced synthetic rubbers, carbon fiber layers, and better adhesives. Modern materials make the game faster and way more specialized. Alright, so now we're going to talk about specifically the rubber's structure and additives. So the rubber is made from a mix of natural and synthetic rubbers. These are usually combined with carbon black, which adds strength and durability. Manufacturers also include tackifiers, which make the surface much more sticky, so players can put super strong spin on the ball by twisting and flicking their wrists. Sulfur and accelerators help with vulcanization, which is the chemical process that basically creates crosslinks inside the rubber. So the rubber is made up of little molecules, whatever you want to call it, compounds, and the vulcanization process connects those, which create much stronger crosslinks, like I said. This gives it its elasticity, really in essence, the vulcanization process does. They also add antioxidants, which just slow down breakdown from oxygen and sunlight. And yeah, all of these additives fine tune how the paddle grips, rebounds, and performs under pressure. All right, here is the actual process of how the rubber is produced. So, first, raw rubbers, fillers, and additives are mixed together. Then the material is sheeted down onto some sort of platform and cooled, so you'll get a uniform sheet of the rubber material. After that, vulcanization happens. This is when the rubber is heated to around 150 to 170 degrees Celsius, so those crosslinks can form and the rubber becomes as elastic, like I talked about. For the sponge layer, gas is introduced to create air pockets, which affect the bounce of the paddle or of the ball. Once the sponge and top sheet are ready, they're bonded together and cut to the correct thickness that they need for the paddle. Finally, manufacturers test the rubber for things like bounce, thickness, hardness, and defects. Quality control is super important because professional paddles have extremely tight performance standards and margins. Alright, so now we're going to talk about rubber properties and why they matter. So there are three main properties that determine how the paddle performs. The first one is elasticity, so the ability to store and release energy. More elasticity means faster rebounds, which is good because speed is something that players want. Second is friction or tackiness. This determines how much spin a player can generate. A tackier rubber grips the ball longer and will give way more spin. All right, third is hardness. Softer rubbers give more control but less power, whereas harder rubbers make the ball fly off a lot faster, so they favor aggressive players. But when you have that harder rubber, it is a little bit less control. So sometimes if a player is looking for more of a technical style of play, they will opt for a softer rubber. Manufacturers mix all of these factors to create rubbers tuned for different play styles. All right, so now I'm going to go over a little bit of impact and applications. So better rubbers make the sport more exciting because players can generate faster shots and crazier spin. When this happens, a lot more interest goes into the sport because people like to watch a fast-moving, aggressive sport, and better materials make that more possible. So, the paddle manufacturing industry also supports jobs and innovation because companies keep trying to design materials that perform better without breaking regulations. This creates jobs for material science engineers, just like hopefully us. Future developments might include nano reinforced rubbers, more precisely tuned elasticity, and even smart paddles that use sensors to track performance. There is still a ton of room for material science to shape how the sport evolves. Overall, understanding the structure of paddle rubber shows how much science goes into something that people usually overlook. Material science directly affects how the game is played, and it will continue to make improvements into how the game is played. Thank you for listening.